Dear colleague, dear student, my name is Juris Purāns. I'm head of thin film laboratory in the Institute of Solid State Physics, University of Latvia. In Latvia is in Riga, the capital of the Latvia. And we are starting a cycle of lecture on chromogenic materials for smart window that include lecture on general lecture, so lecture about electrochromic materials, photochromic, thermochromic, and characterization of these materials. You can follow also my lecture as a professor on different universities at the University of Trento in Italy on the course of synchrotron radiation and course of electrochromic materials in French universities, as well course some about leading about the project, big project on Eurofusion, on creation of a new kind of the steels and materials characterization. So it's, the main topic is materials, and in this course of lecture it is chromogenic materials for smart window. So why we need such materials, and what is the main applications in now and also in future will be for such materials. So according to the environment program as United UN, buildings are responsible about 40% of global energy consumption and 33% of greenhouse gas emission. Moreover, the extremely big number of the million of buildings need to renovate in Europe for energy efficient. If we start speak about energy efficiency, so we must see that new kind of building, that is so building with large glass facade, has significant impact of building energy efficiency windows. As far as you see on this slide, they can be all completely windows glass, or it is at least 80%, 70% of window. And in winter time, the loose have heating demand more for the 35% energy. But in summertime, you imagine it will be increased up to 90%. And so-called window wall, it is really black hole through which is coming we are losing energy of building heating or the cooling. So the demand of this is obviously can be windows like traditional window now, two glazing windows that contain also coating, so-called e-glass, so they cut some infrared radiation. They can improve these properties of window. But as far as temperature around the window or day-night, the illumination change, in this case we need to have adaptive chromogenic materials that follow the change of the flux of the heating and illumination. In any case, it's not only the energy, but also important question of the commodities that for the eyes to use the natural light that coming through the window. As you see in this slide, that our visible spectrum is very straight in the region of the around the 550 nanometer on the maximum, but the total flux of illumination that coming from sunshine, solar spectrum, is covered from UV to the infrared part, and question how to manage all this part of the irradiation. The best, one of the solutions, it is, for example, that we will discuss in the next lectures about some thermochromic, for example, or electrochromic or photochromic that change the transparency in the infrared part or in visible part. But the creation of such adaptive material and window is extremely complicated, as far as we need not only have window for 1 year, it must be have a homogeneous window on really big dimension and stable up to 25, 30 years. Obviously, for such material, we need material stable, inorganic mainly material, because organic materials usually after some years can degrade. So, the question why we start this project in our institute and what is the goal of our project. So our project is so-called Smart Window for Zero Energy Building that include the development and transform technology, knowledge, and creation of the activity to stimulate development of this research in Europe and in the world in the field electrochromic materials, so materials that is sensitive to the electric field, to the change of the intercalation of the ions. Thermochromic, they have changed their optical property by the temperature, or photochromic materials that change the optical property by illumination. So, this project we have started 2 years ago, and so-called it is Horizon Talent Project Era Chair, with the financement coming from European Union, and with the goal to creation of the laboratory and group working intensively in our institute that create the knowledge and transform technology to our institute and distribute. So we have recruited also the ERA chair holder, that it is Dr. Professor Smagul Karajanov. He has done next lectures on this topic, and we have developed many trained to develop technologies, but now I will show some background about this research of the electrochromic, photochromic, and thermochromic materials. So why our institute also? It's also important. The question is, we need to have some background and knowledge in this field, and our institute is leading institute of solid physics in Latvia. It's leading institute in the material science, nanostructure, with fundamental in innovative application, and we have developed in last 10 years intensively the infrastructure, and we have a possibility to develop such project. And one of the topic of this that we have topic of this research of our institute is thin film and coating technology, as you see in this, and clear that this project is extremely important in our development of this direction of institute and laboratory. The responsible of this project is our laboratory of thin film laboratory. I'm head of this laboratory from 2017, and but we have experience about 30 years in the deposition thin films with different techniques, starting from sputtering, magnetron sputtering, high beams, also the thermal MOCVD deposition, and so on. What is the challenge of our project? Is, as I tell, that number of building with such wall facade is extremely growing quickly, and we need to develop and to create the activity in this field for development such materials. And its two goals: it reduces the heat transfer through the window, and suppress visible or ultraviolet light radiation for human eyes, so it will be for comfort of our stay in the window. So, some general classification of type of smart glass, smart window, that obviously it's two parts. It is passive and active. In the passive, we have two kinds of photochromic, that is, we not applied some field or some special by some our hand or some by some other, but it is sensitive for temperature, and photochromic is sensitive for illumination. And the second is adaptive, that is extremely useful for change of our illumination in the building, and it is concurrent also with liquid crystal and suspended particles. About applications of this, we have many review, and it's not new topic, especially topic of electrochromic materials. It's obviously one of the main books, and what it is review published, it is in last maybe 10 years, 20 years, it is coming from group of Professor Granqvist, Professor Nicholson, that is in Uppsala, and you can follow this in books, some books, or in papers of solar energy materials and solar cell. And in principle, so depending on the electricity, light energy, and cooling energy that we need, it can be different application, and for these three kind of photochromic, electrochromic, and thermochromic window. Obviously, it's a big progress in last 20 years. It is done by company. I need to mention company Saint-Gobain, that is a company that started maybe 25, 30 years ago, but after created the company Sage Glass Company in United States. So it is, you can see their product, windows that change electrochromic, the transparency, and they have some bluish the color, but when we go to deeper coloration, it go to the completely, practically black state. The other company that really also on market is very important. It is companies that do roll-to-roll deposition electrochromic materials, and it is Chromogenic company that it is also in Uppsala, created also by group of Professor Granqvist. And their product is known and also tested in some building in real, and it is under estimations that how efficient it is, all of these windows in different environment. Obviously, the question how to produce this is extremely important. In this case, I try to show some pictures from Professor Deb, who was Satyen Deb, who is father of discovered electrochromic materials in 67, 69, and published first paper. And he has done his presentation this last year in a conference of electrochromic materials. And main question, it is also how to produce big such window, homogeneous, and how quickly they change the state from not colored to colored state. And step by step in last 10, 20 years, it is increased dimension of such window to the big window up to 1 meter, 1 meter 20, and up to maybe some 2 meter, depend from construction. But all was started maybe 20 years, 25 years ago from very small, like 10 to 10 centimeter windows. So, how it's working, some words, electrochromic materials. it is an interesting effect discovered in 67, 64 by Professor Deb in the National Center for Energy in United States, and published some small paper that explains the coloration effect. This is next slide. You see that if you apply to the material to electrode some electric field, it starts colored from one part to blue and go to the discolored by application in other direction. Next step was creation of multi-layer such sandwich as a diode system with a photochromic thin film, and it was idea that it can be used as photochromic materials, photochromic plate. Obviously, at this moment was competition with liquid crystal, and as a result, unfortunately, the electrochromic material was start on second position, but liquid crystal for watch was developed up to next step. In the same period, in 70, we have started, I also participate in Latvian University in this laboratory to create such thin films and electrochromic. And what is new was done in our laboratory by Dr. Gunther Byers. He proposed to create like battery with electrode and cathodic and anodic electrode. As a result, the structure of these materials is contain two glass on which deposited transparent conductive oxides. That oxide is transparent and conducting, and on the one, this is B, and C and E, it is two electrode. One is electrochromic electrode, it is tungsten 3 oxide. Another, it is ion storage film that it is usually now nickel oxide, but in this period was iridium oxide. So the electrolyte between these two material was usually or protonic or lithium electrolyte. And we have demonstrated this also device in Expo in Tsukuba in 85. So it was extremely some big accumulated knowledge. As I think it's more developed model was published by Professor Granqvist, as you see here, that they explain that it is coloration, it's coming through the intercalation in tungsten 3 oxide proton or lithium ion, and the decoloration is by the intercalation. In the other electrode, it is reaction of the accumulation of the protons or lithium ion. In this case, change the valence of tungsten 6 plus to tungsten 5 plus, and it is so-called polaronic absorptions that give blue color. For example, such blue color you see on this our old website that we have created 25 years ago, that it's usually in some second it is change of this material color from transparent to blue and blue practically black. Obviously, it depends on dimension of the window. At this moment, the structure is more. It is published for in many books, and the review discusses the structure and some problem and good state on the application of electrochromic materials, that it is starting from transparent conductive oxides that must be not indium but must be much cheaper than indium. For example, zinc oxide with aluminum or others more cheaper oxide. The electrochromic materials has a problem in especially the color, and we have developed also with some mixed oxide to change the color of this material and their properties like tungsten nickel oxide and so on. In the field of counter electrode, it is also progress. We have developed, for example, mixed nickel iridium oxide that give extremely useful decreased number of price of electrode, but also the property is the same one. So it's coming and it is in market and it is developed deposition on big glass or on PET, on the foil that in roll-to-roll machine, but still question of how it will be stable for a long time, homogeneous and so on, still exists, and still it is also a question to improve many things. This is from permission of the Chromogenic company. We have worked for a long time together with Professor Granqvist. Here's from his slide of production of electrochromic materials by roll-to-roll machine. It's some deposition on the PET of nickel electrode oxide, on other it is tungsten oxide, and it is lamination with some electrolyte between these two materials. About physics, you can see this result, maybe some more detail about in some review in Journal of Material Chemistry and so on, or how it's coming reaction. It is obviously this reaction, it is reversible, but must be problem of degradation and so on. Also with some data coming from Chromogenic that we have in internet in other. So the contrast is very good. You see that up to 55% and transparency up to 70%, and in the black state it is about 15. So it's a big contrast. So it's a very, very good product that proposed Chromogenic company in the world. For example, this is changed that optical spectrum. You see bleach state and colored state, and our visible part that we can sensitive. So it is such change of the optical properties of this thin film. So about as far as this system has many, many layers, that it is complicated spectrum coming in bleaching colored state, and it is published also for many times in different review and review of Chromogenic and Professor Granqvist. So it's some spectrum more complicated, but in any case I showed that in previous slide it is good the contrast. The main also important question as we use the magnetron sputtering of this deposition, it is the technology of deposition of this layer, that starting from transparent conducted thin film to deposit is depend on the power, depend on the gas, depend on the temperature of deposition, and so it is many things to be adjust when we have sputtering machine for deposition thin films. So let's go shortly to the photochromic materials. We will have a lecture of Professor Karajhanov in detail about this photochromic material. This is relatively new topic that it is for maybe 10 years on the such active discussion and production. Still we not have a product on the market, but the market is very interesting as far as this is much more simple deposition, the simple system, as we have only one layer that change the photochromic properties by illumination. As I told, this is discovered in 2011 in Oslo and in Sweden, Uppsala, by a group with Professor Karajhanov. He has seen the change of optical properties of thin film yttrium oxohydride under illumination of UV or visible light, and the good reversible changing from colored to transparent state. We have developed in our institute this technology that we have some patent also on the is very specific technology, as we are working with argon and hydrogen, and it not so many laboratory and institute has such possibility to work with these two gases together. As far as in the first step, if you see some machine, here we have machine on our sputtering machine and with magnetron in our thin film laboratory room, but also in clean room. And this is especially interesting process of growing yttrium hydride in first step. It is black conducted thin film, grows in the process of sputtering yttrium by argon with hydrogen argon atmosphere. And after the opening this chamber, we have in some second diffusion oxygen in the material. As a result, the material starts to be completely transparent. All depend also on the sputtering condition of the vacuum pressure, on the power. So it is many, many parameters that you need to adjust to obtain such thin films that is sensitive to photochromic. We have also developed for probably first in the world the deposition roll-to-roll on the PET roll that is in with company Sidrabe, with that we are rolling this film near the magnetron that you see here. The magnetron is that it's yttrium magnetron in the atmosphere of argon and hydrogen, and we obtain many layers. We go up and down, and we obtain such film. But after opening, we see that this film start to be completely transparent and photochromic. You see also such thin film tested in our institute in last year, that created by in group of Dr. Martin Zubkin. So it is good contrast that we have about 30–40% of the cycling. Obviously, the time is very sensitive to the deposition conditions, and we joke with deposition condition, with pressure of hydrogen and so on, argon and so on. As a result, we can obtain very good the properties of such films. But still, we need to improve to have much more maybe stable material and so on. And the last topic that will be presented also by my colleague, Dr. Boris Polyakov, about thermochromic materials that is more sensitive to the temperature and to change in the infrared part of the solar spectra. As I have demonstrated, this from paper. It's for about a thin film of vanadium dioxide. You see that in the visible part, these spectra by changing temperatures practically don't change, but in the infrared, and so we can change completely. You can illuminate the infrared part, and so you can significantly decrease the flux of the heat through the window. At this moment, we have in contact with company that and with the scientific center of TNO in Netherlands. We have visited, and I have took this photo from his website. They created such vanadium dioxide nanoparticles and embedded in some polymer and put by printing electronic on the glass and then laminated between two glasses. So it is a very nice product with big potential application, and we hope that this company will start, as I told, in next years. So the problem of vanadium dioxide, it is to change the temperature changing, that usually it is change of the doping and so on, and why it's known for a long time, but the process of preparation nanoparticles is very complicated and must be very not toxic and and very big control. So this is all about my presentation. So next presentation coming by my colleagues, and you can see this on YouTube and also in our website. You can follow SWAB window website about our activities, recruitment of new person, and the new position will be open. And so welcome to contact with us, and thank you for your attention.